Alright, hi all. So today we will talk about the chapter 4, remote sensing, processing and analysis. So in this chapter, we will discuss on the whole remote sensing processes started from the raw data until you can come up with the map that we want to create. That is what we call as a thematic map. So for this exercise, later we will try to develop or produce a land use data. Okay. So in this chapter, the objective is students are able to perform and execute the remote sensing, processing and analysis, as well as able to select the analysis and algorithms which are suitable for the application. And there are three main chapter outline for this chapter. The first one will be the image correction and calibration, and for the first video, and then for the second video I will talk about the image enhancement, and the last part, for the third video, I will discuss about the supervised and unsupervised classification. And now we look into the image correction and calibration. So before we talk about the correction on the image and so on, remember that in remote sensing, most of the data that we captured is from the satellite images. So satellite images, as in the previous lab, you all have been exposed with the Landsat data. You also has been exposed on how the data looks like, the resolution, the pixel value, the numbers, as well as the other things such as the bands, spectral bands, okay, and so on, the properties of the bands. And now we will talk about the visual image display. And humans are adept with visually processing continuous tone because of, in human nature, basically, we are talking about our eyes, we are talking about the nature, we are talking about how basically all of our environment are in the analog. It's not in digital. Only computer can store digital value, not human. Okay, so it could be in the grayscale and color images, right? So in computer or any electronic device, because of they have this processing, they have this memories and so on, usually they have this what we call as grayscale, right? So every numbers represented by the intensity of the exposure, such as white, and become darker and darker, and for these combinations we produce a color images. So that's why you can see basically on the printer, you can see in the television, your monitors, your handphone and so on, and even there's a lot of things, LCD projectors. And to approximate a continuous tone image using digital data, therefore computer have to understand that computer cannot easily record just like human being record. All right, it must be in the digital value, it must be in the 1 or 0 value. Therefore a brightness map, that is a grayscale image, must be created in the first place. So a brightness map, aka bitmap, so this is what is meant by bitmap, is a computer generated graphic display of digital numbers. So digital numbers, what is digital numbers? Is a representation of the intensity of the brightness value in numbers that only can be understood by the computer. Therefore, what we see from our monitor is basically a representation of the value into a form that human can easily understand. And considering satellite remote sensing, the number of bits per pixel is usually 8. But of course, now you have 12 and 16, and resulting in the possible numbers of 0 to 255. And this color coordinate system used by the most monitor is RGB. You go to anywhere in the computer, Apple computers, you go for the app, for the Macintosh, for the Windows computers, even your handphones, Android, they are using RGB, right? And this precise nature of display is controlled by the size and characteristics of a separate block of computer memory, which is called a color lookup table. All right, so here you see here, right, this color lookup table, this RGB, and you can see all the values here, right? So 0, of course, there's no signal, there's no brightness, it is black. And over the time we expect that there's some a very tiny little exposure and become brighter and brighter until it becomes on the mid gray, and in the end of the day it will become very bright. It will be a white color, right? And by knowing that all of these compositions R, G, and B, so you have the 0. Okay, if R is 0, green is 255, B is 255, this becomes cyan, right? And from here, all of this color is in digital will be converted to analog conversions, where it becomes the display of the monitor that we understand, human understand, because we can't really see, we can't really understand how digital numbers looks like. Therefore, the computer have to convert it into the form that human can understand. And in visual image display, only 3 image bands can be displayed at one time. It explains why our AirDAS system only permits 3 color, although there are some other or we call some other softwares that able you to or permit you to put more than 3 bands, such as PCI Geometrica, okay, which is a very is quite a high-end software for remote sensing, which is very difficult to do, right? But it permits you to have more multiple bands for the processing. And for the typical color composition used includes true color and standard false color, which I already explained, and we also already which I already demonstrate to you in the previous lab. However, many other color composition can be made from the multispectral data, right? So there are 20 of color compositions can be made if we have about 6 bands. Okay, so the combination of the colors, the probability that we have. So before we go about the image probability processing, we have to understand that remote sensing devices are not perfect. That's not perfect at all. Why? Because it's a human made. And the constraints of the spatial, spectral, temporal, and radiometric resolutions introduces error. What kind of error is this? It could be error that intentionally or unintentionally happen on the image or recorded by the image. Example, you have a spatial constraint where it has been decided on the system that for every pixel, the resolutions of the spatial will be 30 by 30 meters. No way you can try to increase it into 10 or 5 meter, because the system only captures on that and you cannot try to improve it. But of course you want to try to reduce the resolution from 30 to 60, that will be no problem, but not from 30 to 10 or 5 meter, you cannot do that. As well as spectral, no way you can come up with a new, or you said that, oh, I want to maybe I want to cut near infrared into 2 segments, from 1 segment to 2 segments. No way you can do that, because it's already recorded physically by the sensor. It's not software generated, it is by the sensor, so impossible for us to try to divide it into 2 and so on. And temporal as well. Satellites, they are moving because of the mechanism of our gravitational force, but because of the orbit, the Earth rotations as well, and also okay, gravity force from the Earth itself. So there are no mechanism to decelerate or accelerate the system, or there are no direction. You cannot just simply turn the directions to go to anywhere they want to go, they want to record. So they have to follow the sequence of the time that has been decided, has been scheduled by the operator. And also, of course, the radiometric resolution. So radiometric resolution is due to the system, the processors, the machines on the system, on the platform itself. And we cannot just simply trying to improve it, try to increase the resolutions. There's no way to do that. And all of this will introduce error, right? So error will affect the accuracy of subsequent human or the computer analysis. Okay, of course, and reduction of the influence of error prior to analysis is very important, because we try as much as possible trying to reduce the error, especially if the error is due to the aging process of the system. And in this case, for technique to minimize error prior to image analysis are called pre-processing steps. So we look here. from the image processing. Okay, so this is the first part of data analysis, where in the first place we already have the data, call it data, it is in situ or through the remote sensing data. Okay, from the various remote sensing images. This is the first place, this is the first step if you want to do the data analysis, the pre-processing. All right, for the digital image processing. Okay, before you go for the modeling, before you go to enhancement, pattern recognition, and blah 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 and so on. Okay.